Let me starting the recording. Good morning, everybody. I would love to introduce our lecturer for today, Mahmoud Hassan. He is the founder and CEO of MVision AI, a Finnish health tech company pioneering AI solutions in radiation oncology. He leads the development of software that automates and standardizes radiation treatment, planning, improving accuracy, efficacy, and access to personalized cancer care worldwide. So, thank you so much for coming, and we're very excited for your lecture today.
Thank you very much. I'm Mahmoud Hassan, a founder of MVision AI. So let me share my screen. All right. So we at MVision develop AI-based software solutions to speed up radiotherapy planning. So a little bit of our mission is to actually enable AI-based solutions to speed up seem to treat from weeks to hours. And our vision is we would like to see a same-day treatment for every single radiotherapy patients. So a bit of history. I founded this company back in 2017 in Helsinki. Prior to that, I used to be a software engineer working for a big vendor developing treatment planning systems. So my background is actually in software systems, complex engineering, and also specifically to in radiotherapy domain. Currently, MVision is installed in 22 countries, close to 200,000 scans is processed, and the team consists of experienced radiation oncologists, therapists, medical physicists, and clinical scientists. Where are we at the moment? So some key facts. For example, in Finland, we handle 80% of all radiotherapy patients, meaning all their segmentation is provided by MVision. Our software is pretty much in 30 plus NHS hospitals. We estimate roughly around 30% of UK patient volume goes through our system. So it's becoming like a very essential tool for NHS UK. And yeah, 22 countries. There are some of the clinical partners. We have quite a few of them, but some of them just for you to see that we have developed something over the last 8 years, and it is actually actively helping patients worldwide. So let me introduce our philosophy of product development. As you know, AI is fundamentally a different kind of systems. From our software engineering perspective, there is a kind of a word, call it software 2.0. As you know, typical software engineering is it's called if you know anything about programming language, it's called imperative programming. So basically, what the programmers do is basically take a condition and then they create like a if this that, some loops and basic data structures and things like that. So with the AI, the definition of that is totally changed. It's now basically called a software 2.0. So I'll just briefly mention what that means. Software 2.0 means basically, instead of having the imperative type of programming, it's basically more sort of a data-driven. The layman analogy would be for a large complex system, you might have 100 million lines of code with 100 engineers or thousands of engineers working over 30 years building a code base. So in AI, it's opposite. So the fundamental AI algorithms are probably few thousand, 10,000 lines of code, but the algorithm actually trained on data, and the data size could be millions, trillions in petabytes as such. The biggest example, of course, everybody knows about the large language model. And as you know, the large language model are basically trained on the whole data of the whole internet, and then they sort of learn it. So that is what it means, software 2.0. So that is the philosophy that we follow at MVision. So that's our kind of technical architecture, but in terms of how we kind of develop solutions, which is more sort of clinical aspect of that in terms of how the workflow is defined and managed as the most important aspect of our company. As we are very experienced in radiation oncology, we did understand the actual pain of protocols and the clinical protocols, and basically how you then implement a clinical way. So from that perspective, the first solution that we developed is called Contour Plus. So it's AI-based segmentation algorithm, and it basically automates the segmentation. That's the product we can primarily sell. But in the clinical workflow, there is a bit of a challenge that we have to address. So I will go through that a little bit later. But for now, in our how we address the contouring is basically we have a solution. We call it guideline-based segmentation solution. This solution comprises of 3 of our products called Guide, Contour Plus, which is the AI algorithm, and Verify, which is a contour comparison tool. This guideline-based AI segmentation provides a very fast automatic organs at risk plus the CTV. So that's the core of the product. And I will go a little bit behind the philosophy as I earlier mentioned. So yeah, this is a very important slide. So that gives takes me to back the beginning days of Envision. So initially, when we started the company, basically, okay, we have the algorithm called UNIT, and we're gonna just take a bunch of clinical data. We train the model, we deploy, everything is fine. So that's the process we took. In 2019, we first launched our prostate auto segmentation product, and then we wanted to, of course, anything in new. We have to generate clinical evidence. So we did a study. In this study, we took the same patient with 4 oncologists. On the left-hand side, they done it manually. As you can see, the lines are all over the places. The volumes are not consistent at all. But then we provided our first AI algorithm, and then they took the AI algorithm, then edited, and the edited version looked like this, and it looks quite beautiful and nice, almost quite consistent. So we kind of measured the consistency increased by 20%, and so everything should be fine, right? Not really. We actually identified a major flaws that might be a challenge in the future. The challenge that we discovered is basically the definition of the lymph node and how it has been interpreted. In the left-hand side, as you see, when the AI actually gave you the definition of the lymph node and delineated, in the left-hand side, as you can see, in the definition of the lymph node, the obturator muscle should not be included. And you see 2 of the oncologists correctly delineated the lymph node without the muscles, and 2 actually included. Alas, the AI was trained with the definition or more data, with the biased data of incorrect lymph node definition, and it included the obturator muscle. So this really, really worried us, basically, that if the AI is just learning from any data, and we are implementing this in the clinical workflow, and then we have no idea how that is interpreted. And I mean, think about that. If you are a Harvard educated doctor, you have a certificate, right? Because it is to certify that you have really studied there, you have gone through all the clinical processes. How do you then certify an AI model that it has been trained with the highest quality of data? There is no control. So we took that matter in our own hand, and what we did in our next version of this model, basically, we discarded all the clinical data. We teamed up with like roughly 25 radiation oncologists. We ran a data processing pipeline and then generated all the training data according to the guideline. And the result, as you can see on the right-hand side, the lymph node delineations are perfectly matching the consensus guideline. Hence, we discovered this method called guideline-based segmentation, which is a trademark product of Envision. So this is super important to understand that the main challenge of implementing AI is basically the output of the AI. How do you know it is the highest quality, or is not biased, it is not hallucinating, and it's not lying to us? And for Envision, the way we address that is every single training data we qualify and verify multiple times before we put that into a training algorithm, so that we can actually say that this product is following the guideline compliant. So yeah, I briefly mentioned how we do the annotation process. We do not take any clinical data. We annotate this data asset in-house with our team of oncologists and clinicians. And that's how we keep the standard of this product high. Anyway, so it is not only prostate. We offer the models for whole body, from brain to the pelvic region, abdomen, thorax, everything. And our solution is tightly integrated with planning systems. It supports all the major planning system. And most importantly, it follows up to 25 different guidelines, namely ESTRO, RTOG, SABR, those are the standards. And these are, and we continuously improve this model because there is always outliers. So you have to always look for outliers and improve the model in the next version to make sure that the model actually generalizes among the whole patient population group. Yeah, just a bit of an advantage of our system, that we also provide some advanced operations to actually that understand the clinical protocol clearly. If you wanted to expand, for example, the heart or muscles or something like that, so we have advanced operation that you can add. So basically, you take the AI and you can also expand and adapt based on your clinical protocols. Yeah, we provide the largest number of ROIs, over 300 organs at risk and lymph nodes. So very detailed, and so what we actually learned, that AI can really scale. In last 8 years, we're able to starting with like 30 ROIs to 300. So this is a fantastic achievement by Envision team. As a brief number of ROI that you have seen, it's actually exactly 311. So we have the largest number of structures that is actually necessary. And sometimes our customers say like, hey, actually, we don't have a DVH for these organs, but at least we are enabling in the future to do toxicity studies because we now provide these ROIs by default. So what is the benefit of having an AI contouring in your workflow? Standardizes, it's turnkey, you don't have to train, you can customize it, it's reliable, flexible, and the model of the AI is getting cleverer every iteration. Yeah, so this AI can be customized based on the clinical need because we understand each clinic has different needs. So we have a full access control in terms of how to configure the system. Also, since we are a cloud first AI first company, we also enable our customers to integrate the solution through a web system or a automatic DICOM router, or even with a treatment planning scripting system. So it's very, very flexible. One important aspect of having a cloud and AI is basically how do you manage the data and privacy, because in the US you have the HIPAA and in Europe you have the GDPR to protect the patient privacy. So we actually came up with a very ingenious way to make sure that we can enable the best of both worlds. So basically we run all our cloud AI models in the cloud, and so basically what our system does, like automatic picks up just the imaging data and then run the AI task and push the result back. So the AI does not need to know any of the patient privacy specific information. So the way we do it is basically, it's really clever. So we de-identify the patient and we keep the de-identification inside a computer memory to make sure extra added protection that if in case there's a hacking happens or something in cybersecurity related breaches, that the hacker would be very difficult to get into the memory. So yeah, in this way, we understand the issue of privacy and we take it very seriously. And I think we have been following this GDPR protocol for last 6 years now. And actually, one interesting fact: 90% of our customers actually choose the cloud systems because it is fast, it is less worry to IT, and the updates are free. So this is the way to go business. Yeah, I mentioned that also it can adapt to your clinical needs. Of course, in terms of planning structures, you need a lot of substructures. So we have like a advanced operations, like a Python-like scripting, so you can like generate scan markers, bolus, or even like a pacemaker, things like that. So this is also augmenting the algorithmic part of that process as well. So yeah, just a few of the example how to do that. Just a bit technical, but it's just to show that that we not only just focus on AI, but we also have other algorithms to kind of truly understand your clinical need. Some clinical examples. So let me just quickly go through that. Yeah, so this is just to give you an idea. Basically, if you wanted to, let's say, get the pelvic bones, landmarks, this is also possible. All right, so it's good that we have a product, but what our customers says, is there any evidence? So we have done a very extensive clinical study over last 8 years. And I think it's in many, these are the geographic region which we have done these studies. And some of the we also won some of the challenges in 2023 in the TROC challenges. The Ambition models were outperformed. It was the best out of the 12 vendors. And in Gastro, in last year's Gastro 2024, we also won the Adapt challenge, where the head and neck and abdomen thorax model was best in class. So as I mentioned, basically that we have a process of generating data in-house. The result is basically the clinicians also agree with this. Yeah, I have a I can share a link where you can find all the publications related to studies. So meaning this product has been time tested and also tested by many top level university hospitals. So now a little bit about the other two products, Guide and Verify. So when we implemented this AI-based segmentation system, then we immediately realized that once the AI is automating that, and the clinicians are reviewing, and maybe sometime by mistake not reviewing, accepting the result, that creates a systematic issues of lack of manual knowledge. It's like, for example, the best example I can find is the airplane pilots. As you know, even though if you're a pilot with 40,000 hours, you still have to do your yearly simulation training, and then different scenario training as well. Even though you are the most experienced, you still have to go a rigorous simulation training process. So Guide is similar to that, basically. So how does this platform work is basically we provide a web-based system where we have a atlases of like around 100 some samples, which has been peer reviewed and approved by clinicians as a like a, let's say, Estro RTOG implementation of different ROIs. And there is a trainee mode and a trainer mode. So the trainer can log in and create different kinds of tasks for the trainees to test. So maybe you're onboarding a new resident oncologist and you wanted to teach them the pelvic or the breast, and so you can create particular tasks to train them. And this platform comes with the automated reference libraries. Create the task, assign, then the trainee logs in and does the contouring. The platform comes with all the editing tools, basically, so you can fast create manually those structures. And once this is done, basically, you can self-evaluate yourself, to meaning like understand where are the missing pieces or where you need to learn more. Also, if you right-click on the structures, it can show you which guideline is following, and it opens up the guideline in PDF format, so you can do a self-paced studies as well. And the second mode is basically an evaluation mode, where basically a task is created blindly to by the trainer, and the trainee then just does the task, and it automatically then sends the result back to the trainer, and the trainer can evaluate whether the trainee has passed the task or not. So we hope or believe that this would be important in the future, to not just having a kind of a more sort of a data-driven approach of training of the system, because in our system you can log this data, and we can sort of over the year also evaluate basically if their contouring skills is staying relevant or missing anything. Well, this is just a recommendation. We are not in any position to force this, but at least for the big opinion leaders, this is something for to consider. And one interesting fact is basically this platform was inspired by Professor Volker Buddha. He was a former head of the radiotherapy department in Charité, Berlin. So when we install our system first, he actually very adamantly told the residents that they are not allowed to use the AI systems unless they can show that they actually learn or they are knowledgeable of the contouring system. So that's how we take that and implement it in our platform. Yeah, so this is a very metric-driven assessment system, and this is really self-service based, web-based, so you can access anywhere in the world. So this is one way to increase the knowledge of the clinicians. Also, we have this Verify tool, which is basically a comprehensive contour comparison tool. So the idea of this is basically, as AI is taking over more and more contouring tasks, basically it would be there is a need for clinicians to compare manual versus AI, or AI product A versus product B. So we provide this a comparison tool. So combining this product, we call it a guideline-based segmentation solution. So in every step of your contouring process, we give you the tools to make sure there are appropriate training is done, and then the AI does the automation, and then there is a comparison tool to make sure that these retained knowledge are applied to every single patient. So there is another clinically regulated product we just released called Dose Plus. It's AI-guided optimization software. And the main idea is that basically when a oncologist has defined the PTV and the prescriptions are not, OIRs has been drawn, with a click of a button, the oncologist can generate a 3D dose to generate a preliminary objective or a starting point for a patient. And so this is a very disruptive new idea. It's going to take some time, of course, because this is kind of new. As you know, from your typical planning process, you have to go through the typical route of optimization process, which might take a few hours to multiple iteration. And the idea is to apply the AI at the beginning of that stage and just give you some guidance of optimization objectives, so then you can speed up the whole process. In our clinical study, it showed that it can say up to 60% speed up the whole planning process by 60%. So this is also a very interesting product. Again, it's a turnkey solution. We do the same thing as the Contour Plus product, basically. We trained different kinds of models, the highest quality planning data, then we train the AI based on that. And of course, it's at least for the contouring, there is guideline, but planning, that's always a challenge. But at least what we believe that this is a good starting point rather than a benchmark that this is the best you can do. So we are kind of slightly turning that around. So basically, if the AI can set a benchmark and the clinical team can do a better plan than that, that's the patient actually benefits. In the same time, it speeds up the whole process. And yeah, we try to, of course, quality control by controlling the training data. Again, it's cloud-based. and you can call it from anywhere in the world. Just needs to send a CT, the structure set, and the prescription, and we generate the 3D dose object. So this is a very new product. So again, we have done extensive validation in Europe and US, and this is some of the results that we have seen. This is one of the attempt to how to implement this AI dose prediction in the workflow. And as you can see, this is kind of quite a new and interesting way of generating plans. And the AI is actually already doing quite good. So in our validation study showed that actually 9 out of 10 times the AI actually outperform the clinical plan. So it has a huge potential to standardize or at least put a benchmark around patient and then improve that from there on. So this is going to be a very interesting new way of generating plan for patients. So yeah, here's an example. The AI versus the manual plan, as you can see, is quite closely matched. So last part of my presentation, just kind of basically show what is the future. After that, I will just show you 3 examples so that this is that how it works. So we are building a future of radiotherapy. We call it a Workspace Plus system. Basically, it's cloud first, AI first treatment decision support system. So it's a TDS, not a TPS. And here the main idea is once the CT SIM is done or any kind of imaging that is available for a patient to make a clinical decision or generate a plan, our platform is capable of doing the AI-based segmentation. Our platform is also capable of generating synthetic CT from a cone beam CT or MRI. Our platform is able to generate a 3D dose prediction with the objectives. And then we also have a technology called AI-based contour propagation or deformable registration. So you can propagate the targets from your planning CT to your daily cone beam CT. With these kind of 4 pillars of our technology, you can actually, from anywhere in the world, able to generate a clinical decision, meaning the organs at risk, PTV, if you know the prescription already, the objectives and the 3D dose. And with that, basically, the remaining task would be to just pass the information to the optimizer to do the final bits of plan calculation, plan QA, and treat. So this is how we think that with a treatment decision support system, augmenting the TPS planning process will enable us a faster, ultra-fast SIM to treat, enabling same-day treatment for every single patient. And at this point, I can take a pause and take a few questions before I show the examples.
Yeah, this is wonderful, Mahmoud. I mean, I will let Saif, so Saif will see if there's any questions from the chat or Q&A. You know, I have to say this is really visionary work that you've done. I think with, you know, when you started talking about this, when was that? 2017, you said it was founded, you know, it's like, you know, this futuristic thing. And now, you know, we are actually in the future that we are seeing this implementation across 22 countries and more are coming, right? So I think congratulations for really setting this up. It's wonderful to see. But Saif, do you see any questions in the chat or anywhere? Let me see.
Yes, I think we have a couple questions. So
I can go ahead and read them off. So our first question is, how do the dose predictions get back to the TPS to create the plan?
Yes, good question. So from the 3D dose, of course, we are creating an interface to extrapolate the objectives. So we have like a sample script. So if you have like, say, Eclipse, for example, then we can provide you a script. So from the 3D dose object, then you just generate the objectives, and then it then populates the whole optimizer.
Great. The next question, how much data do you need to train the AI to segment or identify different tissues that are reliable? And how do you ensure that there's no bias, especially having worked with 22 countries?
Yeah, again, good question. We have diversified our data collection. I think we have 13 different clinical partners from all different regions that we have access to utilize the raw, the CT, MRI data. And then, of course, we generate those segmentation in-house so that it's kind of consistent and follow the guidelines. We're constantly, since we're a cloud-based platform, we kind of monitor the quality issues, and the customers always give us feedback to improve. So we kind of take that on board and then fix the outlier. So the AI, as you saw, these are like model weights, and the model gets more knowledge it gets, is more bigger its brain becomes. So I think we already have it's our maybe 8th or 9th iteration. So it's constantly being updated, and we generate we can just add those outliers to make it more general for worldwide population.
Thank you. Another question, does this work with any TPS, or can it work independently?
Yes, it works with any TPS. So yeah, because we have even some of the older, what is this? I forgot the name. So yeah, we support all the TPSs. Only disclaimer is basically Monaco has a specific issues, but we also provide a added script. You have to add some header file and stuff like that. So yeah, it supports all the TPSs. Yeah, including Monaco, which not probably fully DICOM compliant.
Thank you. Another question. What is the cost what is the cost for these products?
It depends. As I say, every country is different, so we have a pricing model for each country. So that's how we kind of adjust based on the let's say reimbursement or many other topics. So that's something for my sales team to answer.
Thank you. And how do you manage data privacy?
So as you mentioned that once we typically get our system automatically removes the PHI data, or at least in the compliance statement in HIPAA and GDPR. So that's we're making sure that that when we collect the data, we never collect those PHI data. Even in our platform, it has been designed as such that when the scans are sent, it's automatically strips of those PHI data, and it retains that as a cryptographic token inside the hospital's IT system. And then when these processes then complete, the results are then just connected with the cryptographically, then connected back to the correct patient. So yeah, the PHI data never leaves the hospital.
Thank you. The next question is, what is the possibility of integrating the dose and AI guided plan optimization for oncology care in Nigeria? Are there any plans to bring research there?
Absolutely, we are always looking for research partners, and this is more so important as Dr. Hawk always kind of says that AI also needs to understand the different patient demographics. So we are always open, particularly in the African region, as well as in India, and I'm from Bangladesh, all these regions, to also make sure that our AI algorithm is is implementable, that there is no major issues, that can only be done with controlled clinical study. So we are open for that.
Thank you. What was the main problem discovered with the early AI segmentation model?
This was the most extreme one. So when we trained our pelvic model with this lymph node, there is a particular oncologist from one of our partner site. His style of generating the lymph node was very, very different. And then when we kind of generate, I had this lymph node model, and then the doctors was like, what is this? What guidelines follows? We have never seen such a thing. And so that's suddenly we kind of realized that actually, how do you standardize contouring? Then we came to the understanding of these different guideline and implementation. So that is the first hurdle that we kind of came in, because we thought, like, of course, every clinical data is maybe very consistent and all these sort of areas. But for the AI perspective, the consistency and the standardization of data was far from optimal for an AI training. So basically, that was our biggest hurdle, and then we had to take actually quite a huge risk to actually do a lot of R&D and cost on actually curating the data by ourselves.
Thank you. The next question is, to avoid data being stolen from the cloud or anywhere else it is stored, what actions have you put in place to keep that data for patient data safe? And can you talk about the costs to install these data privacy measures?
Yeah, so typically in our agreement, we have like every single agreement, we kind of agree whatever the customer wants. So I just to give you the general framework, since we are a European company, you have to follow GDPR. And part of the GDPR process is basically Envision is a data processor and the hospital is a data controller. And so by these controlling measures, the hospital typically gives us an instruction. Most typically, they ask us to delete the data within 24 hours. So typically, we sort of comply with that request. And the second part is we use the most reliable cloud provider, namely Microsoft Azure, AWS, Google Cloud. And these cloud providers has a very extensive firewall measures, intruder detection, all sorts of things. So that sort of also gives us the network level security or the low level security. And then we have our in-house IT processes actually to follow deleting the data, cleaning, and so that's so it's basically works hand in hand with the providers that we use, and in the same time having our own IT process which follows the European GDPR compliance from all the way. Sorry, it was the question of cost. So I mean, of course, we are providing. I mean, that's it's not that expensive for us.
Thank you. The next question is, how much time does it actually save compared to the traditional starting point of the TPS optimizer compared to where you started from? And can you please elaborate on the outperform clinical plans you'd mentioned?
Yes. So this is a small scale clinical study, and we encourage you to do some more detailed analysis on this. So as part of the regulatory process, we had to do the clinical validation, and part of that, it actually showed that it speed up the planning process by 60%. For a more detailed thing, I need to, of course, involve my clinical physicist to give you a very detailed answer. So that is what we kind of got from the clinical validation study. And what was the second question?
The second part of the question was, you had mentioned outperforming clinical plans. Could you please elaborate on this?
Yeah, so it was basically we took the retrospective plans. That was so then what we done was basically for the same patient, there is a treated plan. We took that plan, and then based on the objectives, we actually created the plan based on the AI, and then we compared. And what we saw that basically, of course, the DVHs and certain organs at risk, the AI it predicted better than the retrospective plan.
Thank you. I'm scrolling through our questions. Does anyone else, if anyone else has any questions, please enter it in the chat now. I'll give a moment.
Yeah, I mean, yes, no, while we're waiting for any additional questions, did you want to show anything else, Mahmood?
Yes, so in the last 4 minutes, I just wanted to show the platform and show you the future.
Yeah,
So I
please.
hope everybody is excited as me. So let me share the screen. Okay. Right, so can you all see my screen?
Yes, we can. Yes.
All right, so yeah, so this is the platform, we call it Workspace Plus, and you have this all AI assistant that kind of does all the automation for you. On the left-hand side, you have the modules, you have the AI-based contouring. You can do both CT, MR modalities. You can call any of the models, then do your contouring task. So once your contouring is done, basically, you can then use our contour editing tool to generate a PTV, and we can also give you a particular script to automatically generate PTV as well, so it can speed up the whole process. And once that is done, then what you can do is basically you can select the appropriate let's say lymph node model, for example, and you can just define the prescription that you wanted to cover. And then when you just start within a minute or so, you will get the 3D dose object. And in that 3D dose, then you'd be able to do the DVH review in more detail. And then here you have this the objectives. What you can do, you can copy it and paste it, and of course we are also writing a script to automate that into TPS as well. So that's what you can do with this dose. Then we have a synthetic imaging module called Image Plus. So for example, let's say that you have a cone beam CT you wanted to enhance, it will then generate the cone beam CT. Let's say that you have a contrast based CT and you wanted to remove the contrast, then our AI can remove
Mahmood,
the contrast.
I'm not sure you're showing us the right screen. We're just seeing, you may want to check again, make sure. Yeah, okay, that's the right screen.
Yes, yes, yeah. Yes, okay. Then there's this AI-based adaptive as well that you can propagate the with the AI, you can propagate your targets from a planning CT to a, let's say, your cone beam or a synthetic CT. So example of a segmentation looks like this. You can download the structure set as well to your, and then you can import it back to your TPS. And you also, for the Eclipse, we have a tighter integration. It automatically connects to the Eclipse. This is our segmentation. And the last one I wanted to show is the synthetic imaging. So here I have a native MRI sequences. And then with the synthetic image system, I generated a artificial CT. It looks like this. And then the added benefit is basically we have the segmentation on the MRI, and with the synthetic CT, you get overlaid on the synthetic CT, and then you can do the dose calculation, so that you can have a very nice looking dose prediction on top of MRI. And I think this is kind of the MR only workflow, and similar way it works with the cone beam CT. So yeah, this is the beginning stages of a completely cloud-based AI-powered treatment decision support system. And I think Envision is the pioneer of this new platform. And I think with your support, we shall fight this cancer. And lastly, I just want to mention, like, you may ask, why am I interested in cancer? And I tell the story, and I will end here. It is one of my auntie when I was little. I remember she had a very hard and struggling life, and then later on she started to do well through her kids was doing well, and all of a sudden she died of a stage 4 cancer, and it sort of really she was quite young as well. I mean, not like 80. So that's the thing. Like basically, cancer is, it's no longer a it's a chronic disease, and the faster we can give this AI solution to as many patients as we can save as many as aunties and our close relatives from this this heinous disease. So thank you for your support. Thank you for listening, and thank you for giving this opportunity. Thank you, Will, Dr. Saiful. I'm really, really grateful. Thank you very much.
Yeah, thank you. And it's really, sorry about your loss. And just, it's really inspirational. Usually that has inspired you, to start, this amazing company that is now going to provide solutions for other people. So you can actually save more lives, even though you lost your family. So that's just always a very powerful, powerful story. Yeah, and we're excited. I remember when you presented this at the Global Health Summit at Harvard some years ago, and we are very glad that you're going to be joining us again in September for the summit at Harvard. And I think really looking forward, really congratulations, and see how you have moved this vision forward. But as you think about collaborations, as the questions were coming in from the chat, I think one thing that we want to do then is really to work with you and extend this system to more low and mid income countries, like in Africa, like the person asked from Nigeria, right? So, and other countries, so that you can save more lives and people can use this. And I also like the fact that you have a pricing model that is adjustable to each country, each setting. So that's really great. That's I think coming back from your own background, in Bangladesh, right? So, so anyway, yeah, thank you so much for joining us for this particular lecture today. I know it just sets up the platform for future collaborations. Let's see if there's another questions from the chat, Saif, before.
I don't believe we have any additional questions. That was a fascinating demonstration, Dr. Hazan, and great presentation. I think the only other thing we have to share in terms of this being our final session for the course is that we have a final survey that we've entered into the chat to be eligible for the certificate of completion. So please complete that. We will be sending out emails in the next few weeks. If you were received a certificate of completion, so please check your emails, check your spam folders in case the emails go there. But other than that, unless any other questions come in, I think we're all set. And I want to thank everyone for their attendance and participation, and for all of our great speakers who made this course what it is.
Wonderful. Yeah, thank you so much, everyone. And I want to acknowledge you, Saif and Dugan and Obame, who worked really well in the background to make this happen. And once more, thank all the participants, and also Mahmoud for taking off time from your Saturday to join us for this, wonderful demonstration at the end of the course. Thank you so much.
Thank you very much.
Bye-bye.
Thank you so much, everybody.